Hi there, today we're looking at quadratics in standard form. And we've looked at these in vertex form before, and the nice thing about vertex form is it gives us the vertex just by looking at the equation. With standard form, that's not quite the case. Standard form is y equals ax squared plus bx plus c, where a, b, and c are just these constant terms. And because the vertex is such a vital part of graphing a quadratic, we still need to find the vertex, all right? So standard form doesn't quite give us the vertex very readily, but there's a little equation we can use to find that. So in standard form, we're going to do the same thing we did with vertex, where we're going to find the vertex in order to graph this thing. But for standard form, I actually have to seek out the vertex. And in this case, the vertex, we get the x value for the vertex by doing this little formula, the opposite of b over 2a, all right? So we're going to take that b value, whatever it is, and we're going to change the sign of it and then divide it by 2 times whatever the a value is. Now that only gives us the x value for the vertex. In other words, that just gives us h. So that's only half the vertex, really. And if I want the y value that goes with that x value, I have to plug that x value back in to whatever the function happens to be. All right, so it's kind of like I'm doing part of an xy chart. I've got the x value once I do the opposite of b over 2a. To find the y value that goes with it, I have to plug it back in. All right, then I'll have my vertex, and then I'll be good to go. Likewise, the axis of symmetry is also x equals the opposite of b over 2a. But remember, the axis of symmetry, we already knew that as being x equals the x value from the vertex. In other words, we already knew that was going to be x equals h. And since h is the opposite of b over 2a, obviously the axis of symmetry is also the opposite of b over 2a. Now, we wouldn't do that little equation twice. Once we have the vertex, we'll just say x equals the x value from the vertex for my axis of symmetry. Okay? So as we look at this thing, if I look at the first one here, I want to do the vertex, so I'm going to do the opposite of b over 2a. So the b value this time is a positive 2. And so if the b value is a positive 2, the opposite of b is going to be a negative 2. So that's going to be a negative 2 over 2 times a. My a value this time is the number that's out front, which happens to be a 1 this time. There's a 1 in front of that x value. And now I just have to simplify this. I've got negative 2 divided by 2, which is a negative 1. So that's the x value for my vertex. That's h. And now to find the y value, to find k, I just have to plug this x value in. So I'm going to plug it into the function. And now I simplify. This gives me a 1 minus 2 minus 3, which is going to give me a negative 4 when it's all said and done. Okay? So I've got negative 1, negative 4 for my vertex, so that's a good start. The axis of symmetry is just going to be x equals the x value from the vertex. And the next thing that I'm asking for here is the y-intercept. And the reason I'm asking for the y-intercept, we could use the a value to graph this thing, just like we did with vertex form. So we could use this a value, know that this thing opens up, and know that it's going to be my standard width. But I can also use a couple extra ordered pairs, and this is what's nice about standard form. Remember, to find the y-intercept of any function, I plug a 0 in for x. So in other words, if I plugged a 0 in for x up here, if I had a 0 here and then a 0 here, I can see that the y value is going to equal a negative 3, so my y-intercept is 0, negative 3. And that's always the case when it's in standard form. The y-intercept is going to end up being this value that's kind of tacked on the end, that c value. All right, that's what's nice about standard form. Yeah, we have to look a little bit harder to get the vertex, but the y-intercept is given to us pretty readily. All right. And then the last thing that it asks here is maximum or minimum. Let's graph this thing first, and then we'll talk about maximum or minimum. So let's see. I've got negative 1, negative 4 is going to be right here. I've got the axis of symmetry. I've got the y-intercept at negative 3. And because I have the axis of symmetry, I can reflect that point on the other side. And really, that's technically enough information to graph this thing. Again, I could use the a value and talk about my standard pattern. This is going to be over 1, up 1, and then over 2, up 4. All right? So I can still use the a value and mimic that original graph that we look at when we talk about parabolas. To get a couple extra points, but really, just those first 3 is enough information to graph this thing. Anything I can do to make it more accurate is great, all right? And now when I look at this thing, I can tell that the vertex here is a minimum value because it's at the very bottom of the parabola, so it's the lowest point on here. So what I have is a minimum. And really, you can tell that right away just by looking at the function. Because the a value is positive, you know you have a parabola that opens up. which means the vertex is at the bottom, it's a minimum. All right. If I had an A value that's negative, that means the parabola would open down, which means my vertex would be a maximum because it would be at the top. Okay? If I look at the next one, again, I'm going to find the vertex, so I have to do the opposite of b over 2a. So in this one, the opposite of b is going to be a positive 1 this time, over 2 times a, which is a 1/4. So that's going to be 1 over 2 times 1/4 is a 1/2. And now dividing by a fraction is the same as multiplying by the reciprocal. So that's actually going to give me a 2 when I multiply that out. And now to find the y value that goes with that x value, I just have to plug it in. So I've got 1/4 times the 2 squared minus 2 minus 4. And now 2 squared is 4 times the 1/4 is a 1. So it looks like this gives me a -5. The axis of symmetry is x equals the x value from the vertex, so it's going to be x equals 2. The y-intercept, if I plug a 0 in for x, I can see that the y value is going to be a -4, so that's 0, -4. Again, it's also that constant term that's hanging at the end of this thing. And now this one, because my a value is positive, I know that this thing is going to open up, which means my vertex is at the bottom, so it means I have a minimum value again for this one. All right? And all of those things are just going to really help us check this as I go to graph and make sure everything's in the right place. So I go to graph this thing. I've got 2, -5 for my vertex. I've got the axis of symmetry. I've got the y-intercept at -4. I can reflect that point on the other side. And really, that's enough information to graph this thing. So I'm just going to go ahead and draw the graph. All right, so I get this nice wide parabola. Let me try that again. Okay, so I got a nice wide parabola, which makes sense because my a value is a 1/4, which means this thing's being shrunk vertically, which gives me a wider looking parabola. Okay? If I look at this one, again, opposite of b over 2a, I want to find the vertex here. So the vertex, I do the opposite of b, which is going to be a positive 2, over 2 times a, which is a -1/2. And now from here, 2 times a -1/2 is going to be a -1, so I have 2 over -1. And 2 divided by -1 is a -2. So I've got half of my vertex. To find the other half, I have to plug that in. So I do the -1/2 times the -2 squared, minus 2 times the -2, minus 1. And now I simplify -2 squared as a positive 4, times the -1/2 is a -2. And then I have a plus 4 here and a minus 1. And so what that gives me is a positive 1 when it's all said and done, when I add those together. And now the axis of symmetry is x equals the x value from the vertex. The y-intercept, I plug a 0 in for x. And when I do that, I get a -1 out for y. Again, it's that constant term that's there. This time I have a negative a value, which means the parabola would open down, which means my vertex is at the top. So I'm going to be experiencing a maximum value this time. And now I go to graph this thing. I just plot each of these values. So I do -2, 1, which is up here. The axis of symmetry. Let me try that again. Making a mess over here. Got my axis of symmetry. I've got the y-intercept at -1, and I can reflect that point over on the other side. And when we look at the width of this thing, it makes sense because it's a little bit wider than our normal parabola, which it should be because of the 1/2, all right? That's what the 1/2 does. Instead of going over 1 down 1, I go down a half. Instead of going over 2 down 4, I only go down 2, all right? I go down half that much. So the a value gives me that quick check to make sure I've done this correctly, all right? When I look at something like this, it says a ball is thrown into the air, modeling the equation h of t equals a -9.8 t squared plus 24.5 t plus 6, where h is the height and t is the time, and I want to know what is the maximum height of the ball. So if I'm asking for the maximum here, and I'm talking about a quadratic function, what I'm really asking for when I ask for the maximum is the vertex, right? This is just a fancy way of saying what's the vertex of this thing, and then we're going to have to interpret what that vertex is. So I'm going to find the vertex, so I'm going to do the opposite of b over 2a. So the opposite of b is a -24.5 over 2 times a, which is a -9.8. And I plug this in. This is a job for my calculator because of the decimals. But when I plug that in, it's going to give me a 1.25. And now from here, that's the x value. So I've got half of my vertex. I need to find the other half of my vertex. So I'm just going to plug this in. So I've got the negative 9.8 times the 1.25 squared plus 24.5 times the 1.25 plus 6. And once again, this is a job for my calculator, so I plug this in. Just be careful as you hit the parentheses here. Make sure you're squaring that 1.25 before you multiply by the negative 9.8 and that kind of thing. And when we do this, it gives me a 21.3125. Okay? So now when I look at this thing, it asks for the maximum height of the ball. Well, the maximum height's not going to be an ordered pair. The maximum height's going to be a single value. So I need to interpret this thing. It told me that h was the height and t was the time. And when we look, h is in the position of y and t is in the position of x. So what I have here is h and t, or sorry, t and h, a little reversed there. So I've got t instead of x, and I've got h instead of y. So if asked for the maximum height, it's just asking for the y value. So the answer to this one is the 21.3125. And that's it. Okay? If I read the next question, the next part of this thing asks me how long does it take the ball to reach the maximum height. Well, how long does it take to reach the maximum height? In other words, what's the time for the vertex? Well, that's asking about the x value for the vertex. So we already have that answer. It's the 1.25. All right. So really, we just have to understand that we're asking for the vertex here because it's asking for the maximum. But then, how do we interpret that vertex? What does each value from the vertex mean? In this case, it's saying that it takes 1.25 seconds to reach a height of 21.3125 meters. And even though units weren't given here, this is a standard type of physics problem where we're talking about meters and seconds. All right. So again, we're interpreting the vertex as being the time and the height, and that's it.